Hello there, this is Wellington with PX5, and today I'll show you how to work with memory allocation using PX5 RTOS. So in this video, we'll run through the memory pool APIs, then I'll show you a 3 minutes video, then I'll share some resources. The memory pool APIs we'll see in this presentation are not part of the standard POSIX pthread APIs. They're actually part of the PX5 RTOS extended APIs. So they all have the PX5 prefix. The memory pool API provides dynamic and variable length memory allocation. Fixed size memory allocation is also supported, but we cover that in a different video. Also, these memory pools work with first fit based memory allocation. So in this example, the first block is taken. The second one is free, but it doesn't have memory enough to support this request. Next one is taken, and the next one is free, and it has enough space to support this request. So PX5 RTOS will allocate this block within this free memory space. So in summary, you need a memory pool for dynamic and variable length memory allocation. There is also support for fixed size, and the memory pool works with first fit based memory allocation. Now let's take a look at the APIs. So before we can use a memory pool, we first need to create one. This process requires a call to the memory pool create API, passing the handle of the memory pool, not any optional memory pool attributes, and then the starting address of the memory area of the pool and the number of bytes in the memory area for the pool. Then we can check the return for errors. And then, once the memory pool has been created, we can start allocating memory from it. We do that with a call for the memory pool allocate API, passing the handle of the memory pool, the destination pointer to return the allocated memory, and the number of bytes requested. As always, checking the return for errors. And finally, once used, we can return memory by calling the memory pool free API, passing a pointer to the previously allocated memory, and then checking the return for errors. Okay, let's see these APIs in action. As always, main starts running and creating variables, thread handles in the memory area. Then, on line 8, we start PX5 RTOS by providing a random number for pointer data verification. We'll talk about that in a separate video. The memory area and the size of that memory area. With that, main will be converted to a thread running at the default priority of 16. Next, to create a memory pool, we need to provide a handle to the memory pool, any parameters we need, in this case null, the starting address of the memory area for the pool, and the number of bytes in the memory area for the pool. See the memory pool created here with 1024 bytes free. Next, to create another thread, the child thread, all we need to provide is a handle to this thread and the entry point for the new thread. Here we can see the child thread has been created with the same default priority of 16, same as main, and it is ready and waiting to run. At this point, main will yield, allowing child thread to run. Child will now update its counter, now at 1, and then we'll try to allocate 1024 bytes from the memory pool. Since this amount was available, it is now taken from the pool. Then child will check the return of this API call. It's okay, it was a success, as you can see here, 0, and it will yield back to main. Let's expand the while loop inside main. Main will increment its counter variable. Then try to allocate 1024 bytes from the pool. We know this is not available, so the main thread will be suspended and the child thread can resume. Note that main was added to the waiting on the memory pool, and 1024 is what main needs. Now child will free up the memory allocated before, and with that, memory is free and main is no longer blocked. Child will now yield. As you can see here, main is no longer waiting and the 1024 bytes have been taken since main resumed. It will now check the result of the API call. It worked well, yields again. Child thread now will try to allocate more memory, which we know is taken. So then child thread has been suspended because of that. Now back to main, which will free up this memory space and start it all over again. That's the demo we had for today. Now that we covered the basics of working with memory pools, you might want to take a look at some additional APIs, like the memory pool destroy, which will destroy memory pools specified in this API call, and the try allocate. This API call try to allocate memory, and if there's not enough memory on the pool, an error is returned. There are several other memory pool related APIs. Please take a look at the user guide for more information. If you need more information about getting started, please make sure to check our website, px5rtos.com. You can email us with questions, requests for information, or a quote at info@px5rtos.com. Thank you for your interest.